Alright, welcome to today's lesson on inheritance, where we're going to expand on our last lesson and look at how to actually modify some of the methods that we've inherited from our superclass. So if you recall from our last lesson, subclasses that inherit from a superclass will get all methods that are contained in that superclass. And we also discussed how we could modify some of those methods in the subclass, but we didn't actually talk about how to do that. So that's what we're going to focus on in today's lesson. So we do this by what's called method overriding. Method overriding is when a method from the superclass is modified, we override it. It's done by creating a new method in a subclass with the same name, return type, and parameters as the method that existed in the superclass. So we exactly just write out the exact same signature that we would have had in that superclass, and we're going to provide our own code for it in the subclass. So for example, I want to create a fast turning bot which is going to extend the super bot that we worked on in our last lesson. This fast turning bot is going to allow us to have a robot that turns 10 times faster than it normally moves. So what would this look like? So here we've got our old super bot, okay, the super bot class we were working with the other day. You can see how it extends the robot class. We've got our constructor, we have a turnaround method, we have our turn right method, and our move3 method. And then I've gone ahead and made a fast turning bot class that essentially at this point has nothing other than a constructor which is going to make a super. So you see how this is going to work. It's going to make a super bot. The super bot will then construct a robot which is going to have all of these methods available to it. Okay, so what we want to do is we want to make an ability to override the turn left method. So we go public void turn left. And this would be the exact same signature we would see in the robot's turn left method. Now how are we going to actually code this? We could write this dot turn left, because we still got to make it turn left, right? We just wanted to do it differently. So the first thing we have to do is make it turn left. The problem with this is if I were to compile this and now try and run it in an environment where I'm going to make a Smithers bot and get them to turn left. So we run this and I press start, you're going to see that it's going to crash here. And if we look, there's a whole bunch of the same error over and over and over again, resulting from a stack overflow. Stack overflow is when I've lost memory. I've got too much stuff in the memory and it has to crash. This is because what's happening here is the turn left method is calling this version of the turn left method, which then calls this version of the turn method. You can see it's going to call itself over and over again. This is called infinite recursion. So it keeps calling itself until it runs out of memory and doesn't know what to do and crashes. So this isn't going to work. So what I need to do now, instead of calling this turn left, I have to call super.turnLeft, which is going to go into my superbot, look for turn left method. Oh, can't find one, so it goes into its superclass, which would be a robot, and runs its turn left method. So now again, if I compile my code and run it, we can see here I'm going to turn left and then move. So we're perfect. But now we still have to add in the added bit about making it go faster. So what I can do now in my fast turning bot, I can add codes in here that are going to allow me to increase or decrease the speed. So I can do this dot set speed, and I increase its speed. And then after I turn left, I want to decrease its speed back down again to 10 times less than what it was. So now I should be able to increase my speed, turn left, and then slow back down again. Again, notice that I'm using this dot set speed because I want this robot to change its speed. So we go here and test it. Let's take a look. Boom. There's a nice fast turn and then back down slow again. Okay. Now, what happens though if in my testing situation, instead of doing a turn left, I want to do a turn around? Now remember, turnaround isn't part of a fast turning bot, right? Turnaround is actually part of the superbot. In superbot, the turnaround method is going to call the turn left method. So what's going to happen? Is it going to turn slow or is it going to turn fast? Which turn left method is it going to use? The one from the superclass or the one from the subclass? Let's try it and see. I need to compile. So now we can try it and see. There we go. It went fast, if you saw that. Went nice and fast. Why? Well, the reason it did that is because I'm calling the turn left method for this particular robot that ran the class. And this particular robot, remember, is a fast turning bot. Smithers is a fast turning bot, so this robot said to turn around. So it's going to run this turn left method in the turnaround class. So this turn back method is the one from the fast turning bot, which is the fast turning. So if I wanted to make sure that that didn't happen, I want the turnaround method to continue to go slow, that's where I would have to, in my superbot here, instead of saying this dot turn left, I would have to call super dot turn left. So now, instead of turning the turn left method of this particular robot, it's going to use the turn left method in the super class. So if we compile it and run it, you can see it turns nice and slow. Okay? So there are some side effects to using this method overriding. The first one we just sort of saw is that the turn left method is going to affect all method that calls it, even if it's a method from the superclass. So if you don't want those methods to be changed, you're going to instead have to make a new method with a different signature so that you're no longer overriding the method you had before. Another side effect is, in this particular case, what would happen if the user changes the robot speed before calling the turn left method? So if I already had my robot going fast, and now he turned really, really fast, what's going to happen is my robot's going to go back to the wrong speed. So if we go back to our code here, my fast turning bot, it's going to go back to a speed of 2. But what happens if my original speed was 10 or 15 or 20? Right? It's going to go back to the wrong speed, so that means I'm going to have to go back and rechange its speed after doing a fast turn left. And that's going to be really frustrating for the programmer. So there's two workarounds we could do. The first is you can just sort of state that problem in the documentation so the programmers know about it and they have to code it. That's kind of a terrible solution. Yeah, it would work, you're aware of it and you can work around it, but not really ideal. So what we have to do instead is the second option, which is going to recode the program so that the robot, instead of turning down to a random speed that we have decided, it's going to return to the original speed that the robot was before it tried to turn. And that would look something like this. So now the set speed, instead of being 20 and 2, we're going to get the speed that the robot is currently running at and multiply it 10. So it's 10 times faster than its speed is now, turn left, and then divide by 10 so it goes back to what its original speed was. So you can see, instead of hard coding a specific value in here, by using variables or queries about the current robot's attributes, we're able to better assess and set that robot to a more dynamic setting. The other thing that we can do instead of method overriding is something called method overloading. Similar concept, but a little bit different. Method overloading is when we have two methods that have the same name but different parameters. So in this case, I could have a move method and a move a certain distance method. Both these methods are called move, but they're different in that parameters that are required in order to run them. What happens here is that Java determines which move method to execute by looking at the arguments that were provided and then matching them up to a method that has the same parameters given. There's no limit to the number of different signatures you can have for a particular method. So if we go back here, I could have 15 different move methods, provided all of them have a different combination of parameters required. And then again, Java will match what you've given to what is required by that particular method. Alright, that's it. That's all we have for today. We'll see you in class tomorrow where we can practice what we've learned.